All right, so for these notes, we are still dealing with inequalities, but we're going to be solving compound inequalities. So just like a compound word, it uses like two words together. A compound inequality is going to use two inequalities that work together. So first, we're going to talk about translating inequalities. So this is where we take words and we turn them into inequalities. So the first example says, while exercising, your target heart rate should range from 100 to 170 beats per minute. So we want it to be between 100 and 170. Now, the way I read that, where it should range from 100, it sounds like 100 itself is good, and 170 is also good. So in our inequalities, whenever you are trying to write between, what you're going to do is take x and write a less than symbol on either side of the x. X is between those less than symbols. And because we want to include the 100 and the 170, I'm going to do less than or equal to. Now, on the left side, I write the smaller number. On the right side, I write the bigger number. Okay, that's important. You're always going to have small on the left, big on the right, and you're always going to include the double less thans. Okay, whenever you're trying to write between, you're going to put x between two less than signs, small number on the left, big number on the right. So what this means is x is between 100 and 170. And again, I include those numbers, so put the or equal to part. And this would be our answer. The next example says water can be present in our atmosphere as a solid, liquid, or gas. Water freezes at 32 degrees and vaporizes at 212 degrees. Now the question is asking, when is water not a liquid? So it's a liquid when it's not frozen or vaporized. If it's frozen, it's a solid. So it's not a liquid when it's frozen, and that happens at 32 degrees. So I'm going to use W this time to represent water. If the temperature of the water is less than 32 degrees, then it's not frozen yet. If the temperature of the water is less than 32 degrees, it is frozen. And the water will vaporize at 212 degrees. If it's anything more than 212 degrees, it vaporized, meaning it's a gas. Now, where it says it vaporizes at 212 degrees, I think that means that once it hits 212, it's a gas now, which means it's not a liquid. So I'm going to go ahead and include that 212. Once it reaches 32 degrees, then it will freeze. So I'm going to say if it's less than 32 degrees, it's frozen. Let's go ahead and include the 32 degrees. If it reaches 32 degrees, let's say it freezes too. I'm not entirely sure on that, but let's go with it. Okay, so today we're going to solve and inequalities where you have like x is less than this number and greater than this number. And we're also going to teach you how to solve or inequalities. So when you are solving and inequalities, that's where you've got like x. That's like the between, the double less thans. Those are our and inequalities. So what you're going to do is you're going to solve and get x alone in the middle. And you're going to have to like solve two sides at the same time, but I'll show you how to do it. Then you graph, it's going to be a segment, like one point to another point. That's going to be the segment. And then you're going to write your interval notation, and it's not going to include infinity for these ones because it'll just be between two certain numbers. So first example, we have negative 11 is less than 3x plus 4, which is less than or equal to 10. So this 3x plus 4 is between negative 11 and 10. That's the inequality right there. This is what I'm trying to solve. I'm trying to get x alone in that. So the first thing I'm going to do, it says 3x plus 4. Get rid of the plus 4 first. So how do I get rid of that plus 4? If I subtract 4, then this will add to 0, right? And I'll be left with just 3x in the middle. But I have to keep it balanced, okay? Normally we have an equation, so we would like subtract 4 from both sides. This time we've got 3 separate parts. So I have to subtract 4 from the middle, from the left, and from the right. So negative 11 minus 4 will be negative 15. 10 minus 4 will be positive 6. Okay, and then I drop down my symbols. So I have a less than right here, less than or equal to right there. Okay, now I'm trying to get the x by itself, and right now there's a 3 multiplying that x. So to get rid of the 3 times x, I divide by 3 because that will reduce down to just 1 x in the middle. But I've got to do it on each part. So I divide by 3 in the middle, on the left, and on the right. Negative 15 divided by 3 is negative 5. 6 divided by 3 is 2. Now, because I divided by a positive number, my symbols stay the same. So that's my solution. X is between negative 5 and 2. So on my graph, I'm going to find negative 5, open circle, because it was just less than. And I'm going to find 2, close circle on the 2 because it was less than or equal to, and it's everything between. So we'll just draw this segment right here. Interval notation, I start at negative 5, I stop at 2, bracket on the 2 because it was included, parenthesis on the negative 5. Next problem. Okay, so I'm trying to get this x right here in the middle by itself. The first thing I want to do is get rid of the 5. Right now that 5 is being added to the negative 2x. So to get rid of the 5, I need to subtract 5 because 5 minus 5, that's going to add to 0 in the middle, and I'll be left with just negative 2x. But I got to keep it balanced. So subtract 5 on the left side and on the right side of that inequality. 1 minus 5 is negative 4. Negative 3 minus 5 is negative 8. Okay, now I just copy down my symbols. This was a greater than, this was a greater than or equal to. Next, I want to get rid of that negative 2. Right now that's being multiplied by x. So if I divide it by negative 2, those will cancel, reduce down to 1x. But I got to divide by negative 2 on each part. So left side and right side. Negative 4 divided by negative 2 is positive 2. Negative 8 divided by negative 2 is positive 4. Okay, now look, I divided by a negative number. So I have to flip the direction of my inequalities. This one will go to less than, this one will go to less than or equal to. And that's my solution. So I'm going to find 2 on my graph, circle the 2, open circle, because it was just a less than symbol by the 2, and find the 4, close circle on the 4, everything between that. So when I write it in inequality or in interval notation, I start at 2, I stop at 4, bracket on the 4 because it's included, parenthesis on the 2 because it's not. All right, so that's solving and inequalities. Next problems, we're going to be solving or inequalities. For these ones, you're going to solve each inequality as 2 separate problems, and then you're going to graph the rays. So you're going to have like one that goes this way, one that goes that way. So when you do that, you're going to have to use negative and positive infinity when you write your interval notation. So here's an example. Negative 2x is greater than or equal to 6. I'm just going to kind of solve this like 2 separate problems. So let's try and solve first this inequality right here. Okay, so I want to get rid of that negative 2. Right now the negative 2 is being multiplied by x. So the opposite of multiplying by x would be to divide by negative 2. Divide both sides by negative 2. This will reduce down to just 1x. 6 divided by negative 2 is negative 3. Okay, now because I divided by a negative number, flip the direction of your inequality. So this will become less than or equal to. The second inequality, Now I'm solving this one over here. So it says x divided by 2 plus 3 is greater than 5. First thing I want to do is get rid of that plus 3. If I subtract 3, this will add to 0, and I'll be left with just x over 2. Subtract 3 from both sides, so 5 minus 3 is 2, and copy my inequality. Now I want to get rid of that divided by 2. Opposite of dividing by 2 would be multiplying by 2. So I'm going to multiply both sides of my inequality by 2. These 2's will reduce down to just 1x. 2 times 2 is 4. I multiplied by a positive, so my inequality stays the same. And now we graph it. So x is less than or equal to negative 3. Find negative 3. Fill in the circle because it was less than or equal to, and everything to the left. X is greater than 4. I find 4. Open circle because it's just greater than, everything to the right. So in my interval notation, I'm going to start from negative infinity, always use a parenthesis with the infinities, and I'll stop at negative 3, bracket on the negative 3 because it was a closed circle. And then we're going to union symbol and include from 4, parenthesis, because it's an open circle, to positive infinity. Again, we're always going to use parentheses on infinity. Next problem, 3x minus 5 is less than 1. Let's solve that inequality first. To get rid of that minus 5, I'll add 5 to both sides, because negative 5 plus 5 adds to 0, and I'm left with just 3x on the left. 1 plus 5 is 6. Keep your inequality, so still less than. Now I want to get rid of the 3. Right now it's 3 times x, so to get rid of it, I'll divide both sides by 3. This will reduce down to just 1x. 6 divided by 3 is 2, and I divided by a positive number, so my inequality stays the same. 2x plus 3 is greater than 11. First, I'll get rid of the plus 3 by subtracting 3 from both sides because this will add to 0, leaving me with 2x. 11 minus 3 is 8, and copy down your inequality symbol. To get rid of the 2, I divide by both sides by 2. This will reduce down to just 1x. 8 divided by 2 is 4. I divided by a positive number, so keep your inequality the same. And now we graph. So I find 2, open circle because it was just less than, and everything to the left. Find 4, open circle because it was just greater than, and everything to the right. So in interval notation, I'm going to start from negative infinity and stop at 2, parenthesis, or starting at 4, parenthesis, because of the open circle, all the way to positive infinity. All right, that's it. You should be all set to do your practice.